Look up at the night sky on a clear evening. If you know where to look, you might spot a faint rust-cold speck drifting against the backdrop of stars, Mars. For decades, it has been the ultimate destination of human imagination. We picture astronauts stepping onto that red dust, planting a flag, and returning home as heroes to a global celebration. But I need to share a harsh, undeniable reality with you. If you step onto the surface of Mars anytime in the near future, you are never coming back. This is not a failure of courage. It is not even primarily about the deadly solar radiation, the razor-sharp dust, or the psychological toll of deep space. It is about the absolute, unforgiving laws of physics. It is about gravity, energy, and a mathematical reality known as the rocket equation. Right now, we are intoxicated by the idea of becoming a multiplanetary species. But the universe does not care about our ambitions. The mechanics of moving mass between two moving planets separated by tens of millions of miles demand a price so steep that our current technology simply cannot pay for a return ticket. I am going to walk you through exactly why the physics trap closes the moment you land. Before we break down the inescapable mathematics of this one-way journey, take a moment to subscribe. We explore the profound and often terrifying truths of reality here, and you will want to be part of what we uncover next. Now, let me show you the invisible chains of gravity that make Mars a permanent exile. To understand why you cannot leave, we first have to understand the sheer, terrifying power required just to arrive. Let us start with something deeply familiar. Think about the last time you packed your car for a long road trip. You loaded up the trunk, you filled the tank with gas, and you drove away. If you decided at the last minute to add heavier luggage or perhaps bring an extra passenger, your car became a "why Mars is more dangerous than it looks" little heavier. Maybe your fuel efficiency dropped a tiny bit, but the solid asphalt road pushed back against your tires, supporting all that extra weight. You barely notice the difference. We take this for granted because we live our entire lives with the solid ground beneath us holding us up. Now, I want you to imagine that to drive down the highway, your car first had to physically lift the entire road, the gas station, and itself straight up into the sky. That is the fundamental difference between moving across the surface of the Earth and trying to leave it. In space travel, there is no road to support your weight. You have to carry the fuel to lift your payload. But because there is no ground pushing back, you also need more fuel just to lift the fuel you are already carrying. This vicious cycle is dictated by a principle we physicists call the tyranny of the rocket equation. Do not worry about mathematical formulas. I want you to simply feel the brutal, undeniable logic of it. For every single pound of cargo you want to launch into space, you need many, many pounds of highly explosive fuel to push it up against Earth's gravity. But that fuel is incredibly heavy. So to lift the fuel that lifts the cargo, you need even more fuel. And to lift that extra fuel, you need still more fuel. It becomes a towering mountain of explosive potential just to put a tiny, cramped metal can into orbit. When you look at the historical of the colossal Saturn V rocket that took humanity to the moon, you are not actually looking at a giant spaceship. You are looking at a giant fuel tank. 95% of that massive towering structure was nothing but fuel, and it was entirely consumed and discarded just to throw a tiny fraction of its total weight toward the lunar surface. Gravity is not just a gentle downward pull. As we understand from general relativity, it is a deep curvature in the very fabric of space and time. Earth creates a massive steep four. The problem with leaving Earth Valley in this cosmic fabric. Pushing away from it is like trying to climb out of a deep, perfectly smooth bowl. You have to move incredibly fast at a speed of almost 25,000 miles per hour just to break free from its gravitational grip and not slide back down to the bottom. Now, let us apply this unforgiving logic to the Mars journey. We pack our astronauts, their life support systems, their food, and their rovers. We build a rocket of staggering proportions to hurl them across millions of miles of empty, frozen vacuum. After months of falling through the dark, they finally arrive. Mars has gravity too. It is weaker than Earth's, only about 38% as strong, but it is still a massive planetary body with its own deep valley in the fabric of space. So, our astronauts land safely. They step out, they explore the rust-cold dirt, and then eventually they want to come home. Here is where the trap snaps shut. To come back, they need a fully fueled rocket waiting for them on the surface of Mars, a rocket capable of blasting them out of the Martian gravity, while pushing them back across millions of miles of space and surviving a fiery plunge back into Earth's atmosphere. Where does that return rocket come from? Where does the fuel come from? Right now, we cannot build a factory on Mars to manufacture thousands of tons of rocket fuel from scratch. That means every single ounce of fuel required for the trip home would have to be launched from Earth in the first place. Let the logic of the rocket equation wash over you again. If we have to launch the return fuel from Earth, we must add that massive weight to our initial launch, which means we need exponentially more fuel just to lift the return fuel off Earth. The numbers spiral out of control immediately. The vehicle required becomes so heavy, so unimaginably massive, that no engine humanity has ever conceived could lift it off the launch pad. We have run How Difficult is a Mars Launch head first into a wall built by the cosmos itself. I know exactly what some of you are thinking. I hear the same arguments from brilliant engineers and passionate space advocates. If we cannot bring the return fuel with us because of the crushing mathematics of the rocket equation, the solution seems obvious. We just make the fuel when we get there. It is a beautiful, elegant idea. In the aerospace community, we call it in situ resource utilization, living off the land. But I want to pull back the curtain on what living off the dead, frozen land of Mars actually entails, because the mystery of our cosmic confinement only deepens here. On paper, the chemistry is simple, almost poetic. The Martian atmosphere is extremely thin, but it is made almost entirely of carbon dioxide. We also know there is water ice buried beneath the rust-cold dirt. If we can mine that water, we can use electricity to split it into hydrogen and oxygen. We then take that hydrogen, mix it with the carbon dioxide from the air, and bake it in a chemical reactor. The result, methane gas and water. Methane and oxygen happen to be phenomenal rocket propellant. In theory, we literally manufacture our ticket home out of thin Martian air and dirt. It sounds like science fiction turning seamlessly into science fact, but performing high school chemistry on a whiteboard is very different from building an autonomous, flawless chemical refinery on another world. I want you to imagine trying to build a massive industrial plant in the absolute most hostile environment on Earth. Let us say the deep interior of Antarctica in the dead of winter. Now imagine you have to pack that entire refinery into a few small metal boxes, shoot it across the solar system, land it perfectly using parachutes and retro rockets, and then rely on it to assemble itself and run flawlessly for years, completely untouched by human hands. Because the harsh rule of mission planning is this: that refinery has to work, and it has to completely fill the physics of traveling between planets' return rocket tanks before we ever dare to launch our astronauts from Earth. This brings us face to face with another fundamental law of the universe: thermodynamics. Creating order out of chaos, transforming stable, low-energy dirt and gas into highly explosive rocket fuel requires an immense amount of power. Where does that power come from? Mars is 50 million miles further from the Sun than Earth. The sunlight there is weak, less than half as intense as a clear sunny day here at home. You would need vast fields of fragile solar panels stretching out across the landscape just to power the chemical reactors and the refrigeration units. And Mars is not a peaceful, sunny world. It is a planet plagued by violent global dust storms that can shroud the entire globe in a choking, abrasive twilight for months at a time. The moment that fine static-charged dust covers your solar panels, your chemical refinery dies, your fuel production stops. The liquid oxygen you spent months meticulously freezing to hundreds of degrees below zero begins to warm up, boil, and vent away into the thin atmosphere. 3. You could try to bring a nuclear reactor to guarantee constant power, but remember the trap we discussed in the first chapter. A nuclear reactor requires heavy, dense shielding. Trying to launch it from Earth puts us right back at the mercy of the rocket equation, demanding an impossible amount of launch fuel just to get the reactor off our home planet. We are caught in a web of contradictory physics. To make the fuel, we need heavy machinery and massive power sources. To bring the heavy machinery, we need impossible amounts of launch fuel on Earth. Even if we somehow manage to land the equipment, the sheer mechanical reality of mining rock-hard frozen dirt at -80 degrees Fahrenheit, filtering it, melting it, and purifying it without a single basils, the fuel problem nobody talks about, broken valve, blown seal, or clogged filter, is staggering. Entropy, the universe's relentless drive toward disorder, is magnified 1,000 times in the unforgiving vacuum and bitter cold of deep space. Every moving part is a ticking clock, a potential failure that sentences the crew to a permanent stay. We look at Mars through our telescopes and see a frontier waiting to be conquered. But the physics of energy and entropy reveal a very different reality. Mars is not a stepping stone, it is a thermodynamic gravity trap, and as we will soon see, the deeper we look into the mechanics of escaping it, the more paradoxical our dreams of space travel become. I want to take you deeper into the machinery of the solar system, to uncover a profound and terrifying paradox. We have been conditioned by centuries of human history to think of travel in a very specific terrestrial way. If you cross a vast ocean in a ship, you eventually reach the far shore. You rest, you resupply, you turn the ship around, and you sail back exactly the way you came. The ocean does not move. The continents stay exactly where they are. This intuition is burned into our brains through thousands of years of evolution and exploration. But space is not a static ocean. It is a dizzying clockwork mechanism of celestial bodies moving at tens of thousands of miles an hour. Earth and Mars are not fixed points on a map. They are runners on a circular track. Earth is on the inside lane, is sprinting much faster, completing its lap in 1 year. Mars is on the outside lane, taking nearly 2 Earth years to complete a single orbit. This brings us to the paradox. To understand it, may think of a massive, intricate grandfather clock. Imagine you are standing on the tip of the minute hand, and you need to leap across to the tip of the hour hand. You cannot just jump whenever you feel brave. The distance between the hands is constantly changing. You have to wait for the exact moment when the faster what happens to the human body on Mars, minute hand, sweeps past the slower hour hand. In orbital mechanics, this precise alignment is the only way we can travel between planets without requiring an infinite amount of fuel. It is a trajectory known as a home-man transfer. To get to Mars, we do not point our rocket at where Mars is right now. Instead, we fire our engines to push our spacecraft into a wide elliptical orbit around the Sun, timing it perfectly so that our ship and the planet Mars arrive at the exact same point in the dark void at the exact same moment. We use the immense gravity of the Sun to do the heavy lifting, coasting along that elliptical path for 7 long months. But here is the trap. The very celestial mechanics that make it mathematically possible to reach Mars absolutely forbid you from coming right back. By the time you complete that 7-month journey and touch down on the Martian dirt, Earth has not been waiting for you. It has been racing around the Sun on its faster inside track. Look up into the black Martian sky, and Earth is gone. It is now on the opposite side of the solar system. You cannot simply turn the ship around, fire the engines, and fly back. If you try, you will be launching into an empty vacuum, chasing a planet you can never ever catch. To come home, you have to wait for the hands of the cosmic clock to align again. You must wait for Earth to lap Mars and catch up. And that specific required alignment only happens once every 26 months. This is the brutal paradox of interplanetary travel. The most energy-efficient path, the only path the rocket equation permits us to take, guarantees that the moment you arrive, you are marooned. You are trapped not just by tens of millions of miles of empty space, but by the inflexible geometry of the solar system itself. For nearly 2 years, you are stuck on a dead world, and during those hundreds of days, a new, even more insidious enemy begins to dismantle our dream of a return voyage. Radiation, the invisible threat. Time itself becomes the weapon. While you wait for the planets to align, the universe does not hit pause. Every single day you spend waiting on the surface of Mars, the relentless forces of nature are breaking down everything you need to survive. Think of a beautifully engineered vintage car left sitting in a harsh desert. Even if you never start the engine, the sun bakes and cracks the rubber, the fine sand invades the bearings, the fluids evaporate, the machine rots from the outside in. Now multiply that decay by 1,000. On Mars, the seals on your pressurized habitats are constantly degrading under wild temperature swings. The delicate electronics in your return vehicle, the very computers you need to calculate your launch, are being blasted and degraded by heavy cosmic rays. The ultra-cold liquid rocket fuel you need to escape is slowly warming, turning to gas, and boiling off into the thin Martian sky. We think of distance as the ultimate barrier in space travel, but I have realized that the true barrier is time. The paradox of the orbital alignment forces us to sit still in an environment that is actively trying to destroy our machinery. You need more time to align the planets for the journey home. But time is the exact thing that guarantees your equipment will fail before you can ever leave. Now I want you to prepare yourself because we have arrived at the point where the problem ceases to be about mechanical engineering, rocket engines or fuel tanks, and begins to tear at the very fabric of human biology itself. This is the break your brain moment. Let me ask you a question that sounds simple on the surface. What are you made of? You might say skin, muscle, bone, and water. But as a physicist looking down through the lens of fundamental forces, you are a symphony of mechanical structures shaped entirely by the exact gravitational pull of Earth. Every single cell in your body, every blood vessel, every calcium seams, what the psychological cost of isolation deposit in your bones has been fine-tuned by 3.8 billion years of terrestrial evolution to push constantly against the downward pull of 1 full G of Earth gravity. We are not independent of Earth, we are physical extensions of its gravitational field. When you spend 7 months falling through the microgravity of deep space and then spend 2 long years living in the weak 38% gravity of Mars, your body does not just adapt. It undergoes a terrifying process of biological unraveling. Think of a grand Gothic cathedral supported by magnificent stone buttresses designed to bear tons of weight. If you suddenly remove the weight, if the structure no longer has to support that massive downward load, the stone does not stay strong. The body's biological construction crews, constantly reading the physical stresses on your skeleton, realize that you no longer need heavy, dense bones to survive. They begin to dissolve your own skeleton from the inside out, reabsorbing the calcium and flushing it away. Astronauts lose significant bone density every single month in low gravity. Your heart, a magnificent mechanical pump that spent your entire life working hard to push blood upward against Earth's gravity to reach your brain, suddenly finds the job effortless. And like any muscle that stops working hard, it atrophies. It shrinks. It rewires its own vascular network. Now imagine our crew has waited out the 2 long years on the Martian surface. The planetary alignment finally clicks into place. Miraculously, the autonomous refinery produced the fuel. The return rocket fires and they blast off Mars. They spend another 7 months floating back through the empty void. They arrive back at Earth. They plunge through the upper atmosphere. The parachutes deploy. The capsule slams into the ocean. The journey is complete. They have returned home. Or have they? Here is the what if Earth is no longer home. Heartbreaking reality. The human beings who left Earth do not exist anymore. When that capsule lands on Earth, those astronauts will be instantly slammed with the full crushing weight of 1 gene to their wasted muscles, their thin, brittle bones, and their shrunken, weakened hearts. The gravity of their home planet will feel like a lead weight pressing down on their chests. When they try to stand up, their cardiovascular system, remodeled for years of low gravity, will completely fail to push blood to their brains. They will black out instantly. A simple stumble, the kind of clumsy misstep that would give you a minor bruise on a sidewalk, will shatter their brittle leg bones like dry glass. They are returning to a world whose physical constants their bodies can no longer tolerate. And it gets even stranger. Deep space and the Martian surface are saturated with high-energy cosmic rays, atomic nuclei stripped of their electrons, and accelerated by distant exploding stars to nearly the speed of light. On Earth, our thick atmosphere and strong magnetic shield protect us from these cosmic bullets. But out there, they slice straight through metal hulls and straight through human tissue. These particles do not just cause radiation sickness. They physically shatter the delicate neural pathways in the brain. Over a 3-year mission, this radiation wrecks cognitive processing, degrades memory, and damages spatial reasoning. Look at what this means. The very qualities that made these astronauts the elite of our species, their sharp intellect, their rapid reaction times, their physical resilience, are stripped away by the harsh physics of the universe during the voyage itself. We dream of the triumphant astronaut walking out of the recovery capsule, waving to a cheering crowd, but physics paints a completely different picture. The returning traveler would be a physical invalid, confined to medical stretchers. Could humans become a different species? Suffering from cognitive decay, very physically incapable of surviving in the heavy gravity well of the planet that gave them birth. You see the profound truth now. You cannot come back from Mars because the voyage itself destroys the biological machinery you need to live on Earth. You leave as an Earthling, but the universe reshapes you. If you go, Earth becomes a deadly toxic environment of crushing weight and lethal gravity. You cannot come back to a home you are no longer built to inhabit. I need you to step back and look at the complete picture we have just painted together. We have run headfirst into the mathematical wall of the rocket equation. We have faced the thermodynamic nightmare of manufacturing fuel in a frozen, irradiated desert. We have seen how orbital mechanics trap us in time, and we have witnessed how the deep space journey itself fundamentally dismantles the biological machinery required to survive on Earth. When you stack these absolute laws of physics on top of one another, they are not just engineering hurdles waiting to be solved by a clever new technology. They are a profound message from the universe itself. I want you to listen closely to this. The reality you experience every day hides a terrifying and fascinating secret about the nature of exploration. We are trying to force a symmetrical solution onto a universe that operates entirely on asymmetry. You can shatter a glass cup, but you cannot unbreak it. You can burn a log into ash, but you cannot unburn it. The laws of thermodynamics dictate that certain processes only move in one direction. The hard truth, the reality we are so deeply reluctant to accept, is that our expansion into the solar system is one of those irreversible processes. We are victims of our own history. We view space exploration through the lens of early global explorers sailing across the oceans. They left port, they mapped new coastlines, and they rode the winds back home to tell the tale. But the void, the strange effect of time in deep space of space, is not an ocean, and Mars is not a new continent. To understand what is truly happening, I need you to think about a much deeper history. Think back hundreds of millions of years to the precise moment when the first brave aquatic creatures dragged themselves out of the ancient waters and onto the dry, rocky shores of Earth. When those ancient ancestors left the water, they did not build pressurized suits to carry the ocean with them so they could eventually go back. They left the ocean forever. Their bodies adapted to the crushing weight of gravity in the open air. Their gills evolved into lungs. Their fins hardened into limbs. Once that profound biological threshold was crossed, they could never return to live in the deep ocean trenches. To them, the ocean became an alien, lethal environment. They sacrificed their first home to inherit a new one. We are standing on that exact same evolutionary shoreline today. We look at Mars through our telescopes, and we think of it like a daring camping trip. We think we can pitch a high-tech tent, plant a flag in the dirt, take some photographs, and ride a rocket back to a parade. But the unbreakable laws of physics and biology dictate that stepping onto Mars is not a camping trip. It is a permanent evolutionary severance. If we send human beings to Mars, they must go with the absolute chilling understanding that they are saying goodbye to Earth forever. They are not just astronauts on a scientific mission. They are the seeds of a completely divergent branch of the human species. Think about the children they will eventually have. A child born in the 38% gravity of Mars will grow taller than anyone on Earth. Their bone density will be fundamentally different. 3. Their cardiovascular system will be engineered by nature for a light floating existence. If that Martian teenager ever why Mars could become a one-way journey, tried to visit the planet of their ancestors, the invisible hand of Earth gravity would crush their chest. They would suffocate under their own weight. Earth, the beautiful blue marble that gave birth to humanity, would be a terrifying, very lethal hellscape to them. This is the hard truth of becoming a multiplanetary species. The universe demands a sacrifice for leaving the cradle. We are so obsessed with the idea of the heroic return because we are terrified of the finality of letting go. But the physics of the cosmos do not care about our nostalgia. The invisible chains of gravity, energy, and time mean that the moment human boots touch the red dust, the umbilical cord to Earth is permanently severed. We can reach Mars, yes, but to do so we must accept that we are never coming back. I want to bring you to the very edge of the launch pad. We have systematically dismantled the romantic illusion of the round trip. We have looked at the brutal mathematics of the rocket equation, the thermodynamic nightmare of producing return fuel in a frozen desert, the clockwork of the solar system that traps us in time, and the biological reality that Earth will become a lethal gravity well to anyone who leaves. You might feel a sense of profound sadness right now, a sense of confinement or loss. But as a physicist, when I look at this inescapable one-way journey, I do not see defeat. I see the most beautiful and terrifying mechanism of the universe at work: transformation in physics. There is a concept called the arrow of time. It is driven by the second law of thermodynamics, which states that entropy or disorder always increases in an isolated system. You can drop a glass and watch it shatter into 100 pieces, but you will never see 100 pieces of glass spontaneously reassemble themselves into a perfect cup. The universe only moves forward. It demands irreversible change. Think about the could humanity become a multiplanetary species? Stars scattered across the night sky. For billions of years, a massive star burns bright, holding itself together in a delicate balance between the crushing inward pull of its own gravity and the outward explosive push of nuclear fusion. But eventually the fuel runs out, the balance shatters, the star collapses and then explodes in a supernova, violently ejecting its outer layers into the freezing void of space. That star is destroyed forever. It can never be put back together. But in that violent one-way expansion, it creates the heavy elements, the carbon, the iron, the oxygen that make up your blood and your bones. Destruction of the old state is the universe's absolute prerequisite for the creation of something new. Humanity leaving Earth is a biological supernova. We have been gestating in the warm, perfectly balanced gravity well of our home planet for millions of years. But to spread across the cosmos, we have to shatter that balance. The individuals who strap themselves into the top of that towering mountain of explosive rocket fuel will not be explorers in the traditional sense. They will be cosmic pioneers undergoing a deliberate, agonizing metamorphosis. I want you to imagine the psychological weight of that moment. Put yourself in their seats. The engines ignite. The crushing forces pin you to your chair. You pierce the thin blue line of the atmosphere, and you enter the black void. You look out the small window and you watch the Earth, the only home your ancestors have ever known. Very slowly, Brian Greene's bigger question about our future shrink into a pale blue dot. You are not thinking about the ticker tape parade you will never have. You are thinking about the fact that your molecules, your DNA, your future now belong to another world. You are sacrificing your identity as an Earthling to become the foundation of a Martian civilization. It requires a level of courage that defies human comprehension. The courage not to return as a celebrated hero, but to disappear into the dark and become a silent ancestor to a future you will never see. This is the raw, unvarnished reality of the cosmos. The universe is not a fairy tale written for our comfort. It is a vast, indifferent machine governed by absolute mathematical laws. Uncovering these truths, peeling back the comforting illusions to reveal the stark and magnificent mechanics of reality is exactly what we do here. We do not explore these dark concepts to feel despair. We explore them to understand our true place in the machinery of existence. If these deep dives into the physics of reality shift your perspective, if they make you look up at the night sky and feel the profound weight of our place in the universe, I ask you to support this work. Directly beneath this video, you will find the Super Thanks button. The final thought, can we really come home? Using it is the most powerful way you can ensure we continue to unravel these cosmic mysteries together. Every single contribution allows me to dedicate the time required to break down these complex, mind-bending realities into the undeniable logic we share here. It is your support that keeps this relentless pursuit of the truth alive. We have established that we cannot come back, but there is one final philosophical question we must answer before we close this chapter on human destiny.